Hello everyone. In this video, I'm going to talk about law of conservation of energy. Um, and the learning intention for this experiment that we are going to work on is about testing the law of conservation of energy. And other part of the experiment is height versus potential energy. So let's try to understand what mechanical energy is. So as we know, mechanical energy is a combination of potential energy and kinetic energy. Potential energy is dependent on height and kinetic energy is dependent on velocity. And we are going to rearrange these equations and try to prove that the energy for the car at the top of the ramp is the same as the energy at the bottom of the ramp. So I'll get into the details of the experiment and the tables and the graphs that are required. But the purpose of the experiment is to see two things. One is how the height affects the potential energy and how to calculate the velocity and check if the energy is conserved. And you need to be able to draw graphs between height and potential energy and show that they are as directly proportional to each other. And then for and then test if potential energy is the same as kinetic energy, and model that on your graphs. Now, in general, we need to know that mechanical energy is the sum of kinetic energy plus potential energy, where there is no loss in the system. Okay, and let's review quick ones concepts. Understanding potential energy is the energy that the objects or the system hold without any movement. Okay, so when it is in the state of rest, the energy, the invisible energy that is held by the object, that's what is potential energy. Now we are going to see if potential energy is directly related to the height. That means if the height is increased, will we have more potential energy? And we're going to test that. So m is the mass of, so in the equation, m is the mass of the object, g is the acceleration due to gravity, and we treat this as 9.81 meters per second square on the earth, and delta h is the change in height of the object within the gravitational field. All right, so there's definition of work, force, and energy. Energy is the capacity to do work or produce the change. So in our experiment part A, we are going to test if potential energy is related to height. So as we increase the different heights, we are going to see how the potential energy is increased. Now, how do I know that? I'm going to test by putting an egg at the end of the ramp. So and see at what height will the egg will crack open, assuming that there was more energy to produce the work of breaking the egg. So that's the experiment idea. Now, how do we calculate? So, for example, in this case, the height is given to you as 5 meters. So the mass is 3 kilos. So we treat G as 9.81. So just substitute into the formula. And there we go. Now let's take a quick look at kinetic energy. Energy of an object because it's moving, possessed by the object, right? So it is half times mass times velocity. So velocity squared. So these are the units. Now, when you swing, you have kinetic energy at the highest point. As you go down, kinetic energy changes into potential energy. So that's why the mechanical energy is the sum of kinetic energy and potential energy. Now, there's another example. When a car stops, its kinetic energy decreases. The brakes transfer the energy into the heat energy. Energy is not lost, it just changes its forms. We all know that. Um, I'll give you a quick question, food for thought. How would a roller coaster create energy transfer? Can you can pair share at your tables with your partners, right? Come up with another example of kinetic energy transfer. All right. So when you have a question to calculate, for example, calculate the kinetic energy of an object with a mass of 4 kilos and a velocity of 25 meters per second, all we need to do is we just substitute into the formula, and that's what it is. So today's experiment is inspired from a YouTube video where they have, it's called Hotwheels Labs, where they used Hot Wheels and Hot Wheel tracks, and that's how they have demonstrated this energy of potential energy transferring into kinetic energy and how the work is done. All right, guys, let's get into the technicality and how you record your quantitative data. All right. Um, all right, let's figure out how to calculate quantitative analysis of this experiment. So, for our experiment, what we are going to do is we will, in the first part, we are experimenting how potential energy is dependent on the height. And these are the requirements that you need. We are going to use a small Hot Wheels car. We are going to make use of Hot Wheels tracks, 10 of them. Each track is 10 centimeters long. We need some X, we need some glass jars, and we, just in case, we also need a stop clock. Now, before you proceed with the experiment, make sure that you understand the risk. You are having a flying object because when you release a car down the Hot Wheel track, it can fly. And if you forget to look out, it can roll over. And if you forget to leave it on the floor, you can slip and fall. And also, you're working with an egg here. So make sure that you're careful with your biohazards. Cleaning must be done immediately. And also, to hold the egg at the end rather than allowing the egg to be unstable, we are using glass jars, glass containers, so there can be sharp objects if it cracks. So keep that in mind. Next, for our data collection, we will make use of few understand. I mean, before you proceed, you need to understand what are your independent variables, dependent and control variables. Your independent is the mass of the car. Your controlled variables, I am controlling the height, and then I'm not using any additional force to push. And your dependent variables are going to be calculating the potential energy, kinetic energy, and then the angle of inclination or the ramp angle. So after you do that for the first table, once you measure the mass of the car, this is going to be the same. This is independent, and this is our gravitational constant. So you're going to make use of the formula and replace the h with the different heights and calculate the potential energy. Then for your velocity, since if the energy is conserved, the energy at the top of the ramp should be equal to the energy at the bottom of the ramp. So assuming that Ke is equal to Pe, you're going to find your V. And when you're trying to plot this graph, it should look something like that. As the height increases, your potential energy should increase because they're directly proportional to each other. Then when the second part, the kinetic energy, we are going to release the car. So here, your velocity is actually 2gs sine theta. So your displacement, this is just an example for you how to do the calculations. Here they have assumed the track length to be 6 meters, but in our case, we are using only 10 tracks, which is 3 meters long. So you would be using three. All right, so just do the square root of this. Now, to understand the formula, here, V is 2gs sine theta. So you're also changing theta because you're changing the height. So if you look at your previous picture, when the height increases, this angle will change as well. So you need to measure the angle using a protractor and then substitute into the formula and get the velocity. And once you get the velocity, you just have to substitute into the kinetic energy equation and calculate the kinetic energy for each individual light. In this way, you can compare it with your table one and see if the total energy of the system is conserved. All right. And when you graph these two energies over time, so when the kinetic energy is zero, remember that the potential energy is the highest. So the total energy of the system is only the potential energy. But over the time passes by, as the potential energy is decreasing, your kinetic energy is going up. So that's how you would come up with this graph at your table. And for the discussion questions, please make sure that you comment on graph one, graph two, identify major sources of loss of kinetic energy, write about it. And then these are the two extension questions where you have to recalculate it. My favorite one would be this one. What if you are trying to crack this egg on planet Mars? How would that change? All right. So because G is now 3.71. So discuss at your table, and this would be a fun experiment for you to proceed.
Go. Oh, okay, go now. Go. Yeah. Good. Go. Yeah.